All right, I want to highlight this problem because I just want to show you that there's different boats on and off the island. Okay, so again, we draw our island around this whole thing. What it means is every transaction on the island is in moles. Okay, so we have this problem. We could read it all. The surface atoms of aluminum metal corrode in air to form impervious aluminum oxide coating that prevents further corrosion. The oxidation reaction is blah blah blah. And it doesn't really, doesn't have to tell you. You don't have to know what any of those words that I just said mean. Okay? So let's start right here and say how many micrograms, okay, so that's important, micro, of Al2O3. So how many micrograms of that stuff form, and let's call that one that color, form when 10 micrograms of aluminum, so 10.0 micrograms of aluminum does a reaction, okay? And it doesn't say have anything at all to do with with oxygen. It doesn't tell us anything at all about oxygen. We don't even mention it. So who cares? We're just going to go. We're going to get on our boat here. We're going to ride into this port. We're going to go to aluminum. We're going to then convert that over to this, and then take that off and get on that boat. Okay? And then the second part is how many atoms of aluminum is this? Now, oddly enough, that's a problem we could do without even having a chemical reaction. Okay? We don't even need a chemical reaction to do the second part of this problem. They could have asked us how many molecules of Al2O3. That might have been a better problem. But that's okay. It doesn't really matter. So let's just figure this out. Same kind of concept, okay? We're going to start with this. We're going to start here, and we're going to end here. Okay? So, to start. Oops, sorry. So we have, again, 3 sig figs. So that's what our answer has. We don't have to even think about it when we do our problem. So we could just write 10 micrograms of aluminum. We don't have to write 10.0. As long as we remember there's 3. If you're not going to remember there's 3, it probably is good practice to write 10.0, okay? Now, we first have to get to grams, because that's how molecular weights work. So let's just get to grams. So remember, keep it positive. 1 times 10 to the 6 micrograms of aluminum. 1 gram of aluminum. And then aluminum is 26.98. I don't know what song this is. It's not our mole or our island one anymore. Okay, 1 mole of aluminum. Now we have 4 moles of aluminum. Right? That's our problem up here. And we have 2 moles of Al2O3. And then for every 1 mole of Al2O3, there is 101.96 grams of Al2O3. And then just like we did when we got on the island, we're going to have to remember for every gram of Al2O3 is 1 times 10 to the 6 micrograms. It's 2 steps away, so millimicro. So 2 steps away, so 10 to the 6. So what that does is that equals 18.9 micrograms Al2O3. That's our answer. 3 sig figs. Okay. So you identify everything, identify which boats you need, and then get to the island, do your thing on the island, get off the island. That's what we do. Now for the last thing, how many atoms of aluminum is this? Okay, so the point of this is I want to show you that, remember, we have different boats that go to the island. So we have a mass boat, but we can also have an atom boat, atom/molecule boat, right? So atom boat, and these can go both directions, so they can go to or from the island. But remember, the important thing about an island and the important thing about thinking of it this way and why I draw it this way and why I constantly talk about it this way is you can never go from directly from mass to atoms. That's not a transaction. You have to go mass to moles to atoms. Okay, you cannot go from one boat to another. There's no boat jumping. Okay, so you start the same, 10 micrograms of aluminum. 1 times 10 to the 6 micrograms of aluminum, 1 gram of aluminum, 26.98 grams of aluminum, 1 mole of aluminum. And now we're going to take a little jump and get on a different boat. For every mole of aluminum, there's 6.02 times 10 to the 23rd atoms of aluminum. Okay? So that ends up, you put that all in your calculator, do the thing. So it's 2.23 times 10 to the 17 atoms of aluminum. Okay? So that's how much we have. Okay, so we can go grams, we can go to atoms. Those are 2 things we've learned so far. All right. Done with that.